After 40 million man-hours of work, huge cost overruns and delays, which have made the length from the time of conception to launch longer than the entire Moon program, including Mercury, Gemini and Apollo, the James Webb Space Telescope is almost ready to launch. But even at the last moment, an incident during the final preparations for loading it onto the launch vehicle has pushed back the launch date 4 more days to the 22nd of December 21. Hopefully, if everything goes well and the deployment 1.5 million kilometers from Earth is successful, the successor to Hubble can start discovering things that Hubble couldn't. But closer to home, Hubble isn't dead yet, and even though it's been having a few senior moments recently, Hubble has been one of the most productive space programs of all time and could go on even longer if a way to service it could be found since the demise of the Space Shuttle. This is the story so far of the Hubble and Webb space telescopes. This video is sponsored by NordVPN. Now, if you're interested in keeping a low profile out there on the internet, keeping prying eyes from trying to gain access to your computer and the important information it may be holding, then it's very important that you keep it as safe as possible. One of the best ways is to use a VPN, like NordVPN, which is what I use. Using a VPN hides your computer's real IP address and makes it much more difficult for hackers to gain access to your computer. But it's not all about logging into your bank account. The number of times I get blocked from US websites when I'm researching for videos because they detect I'm in Europe, and although we are in the UK, we are not in the EU now. But with Nord, I can just reappear as if I'm somewhere else in the US or Canada, and I can continue. NordVPN also uses NordLynx technology, which is built around the WireGuard protocol and is even faster than before and outperforms any other mainstream VPN protocol, with users experiencing up to 2 times increase in download and upload speed with NordLynx. You can get your Black Friday offer of 73% off plus 1 month free by using the link in the top of the description below, and there's even a 30-day money-back guarantee, so there's no excuse for not trying it out. Big projects like the James Webb Space Telescope are often beset with delays and problems. The Hubble itself was no stranger to controversy. Designed in the 1970s, it was due to be launched in 1983, but with technical issues, budget restrictions and the Challenger disaster, it was delayed for 7 years. Only when it was in orbit did they find the most perfectly ground mirror in history had been made with a tiny error in its shape, effectively making it short-sighted. It took a further 3 years before a fix was created and applied to finally get it working as it should. The Hubble was designed to be serviced and upgraded in orbit, and over the last 25 years, it's undergone 5 service missions. This was all done using the Space Shuttle, and at the end of each mission, the Space Shuttle would move the Hubble to a higher orbit. This was done because although Hubble is in orbit, the height of the orbit is still low enough to be in the very, very thin upper atmosphere of the Earth, and this creates drag, which slows it down even very slightly over an amount of time. This slowing down causes the orbit to decay and become still lower, which increases the drag, which slows it down more, and so on and so forth. And if nothing is done, it will eventually crash back to Earth and burn up. The problem is we no longer have the Space Shuttle to do any of the servicing or boost Hubble's orbit. So even if nothing else goes wrong, Hubble will eventually fall back to Earth somewhere between 2028 and 2040. This is a rather vague date because it's the Sun's activity that affects the expansion of the Earth's atmosphere and ultimately the drag on Hubble, and that's something we can only estimate in the future. It wasn't planned to end like this though. One of the scenarios was that the Hubble would be brought back to Earth by the shuttle and be placed somewhere like the Smithsonian Museum. But with age comes random component failure. Earlier this year, it was taken offline when the payload computer, which was built in the 1980s, stopped working. Engineers eventually traced a fault which turned out not to be the computer itself, but the power control unit, which supplies the computer with power, and it's thought that this is sending out an incorrect voltage. and the computer's failsafe shut itself down automatically. Luckily, a backup was fitted in case of such a power supply failure like this. But one day, there might not be a backup available, and without a service mission, that could be the end for Hubble. What will happen to Hubble in the end is still unknown. There have been ideas put forward to boost its orbit with specially adapted rockets, but without something like the Space Shuttle's payload capacity to return it to Earth, it seems more likely it will end up in a fireball crashing back to Earth than in any museum. While some like to think of the James Webb as Hubble's replacement, the two are very different, and NASA would say it should be seen as its successor. Hubble was built on the same platform as a US spy satellite and was designed primarily to operate in the visible to ultraviolet spectrum with limited infrared capabilities. Using the information discovered by Hubble, the James Webb was designed to operate primarily as an infrared space telescope with a much larger mirror at 6.5 meters compared to the 2.4 of a Hubble. This allows it to see far fainter, more distant, older objects, the light from which has been shifted from the ultraviolet through the visible to the far infrared. Infrared is also not blocked by dust clouds like ultraviolet, so the James Webb will see things that are hidden from Hubble. At the orbit of the James Webb, it will stay in the same position relative to the Sun and the Earth, so that its large solar shield will block the light and infrared from the Sun, Earth and Moon from its highly sensitive instruments, which operate at less than 50 degrees above absolute zero or minus 223 Celsius. And it's this final position which is why the James Webb is taking literally so long to get off the ground. Unlike Hubble, with or without the shuttle, if something were to go wrong with the James Webb, it would range from extremely difficult to nigh on impossible to fix, because we just don't have any manned spacecraft capable of travelling that far out. It's been estimated if something did go wrong, it could take 40 years before a craft and crew capable of getting there and fixing it would be available. So the James Webb was designed not to be serviced, so everything has to work perfectly, which means testing, testing, and more testing, and even testing the tests. The memory of the Hubble fiasco, which was basically down to a failure of testing, looms large in the minds of Northrop Grumman, the primary contractor, and NASA. A failure here would be very hard to live down. The other issue is that no one has built anything quite like the James Webb before. At the time of its conception, at least 10 of the technologies required had yet to be invented. Things like the giant 5-layer sunshield, the size of a tennis court, that will take 2 weeks to deploy from its folded up form. And it's not only the detectors, but also the sunshield mechanical control systems that have to work at less than 50 degrees above absolute zero. Everything on the detection side of a telescope must also be as cold as possible so as not to interfere with the tiny amounts of infrared light that the James Webb is looking for from the farthest reaches of the universe, from the first galaxies that formed just after the Big Bang. This includes the mirror, which at 6.5 meters across has 6.25 times the light gathering area of Hubble's 2.4 meter mirror. A single mirror this large wouldn't fit into any spacecraft, so it's made up of 18 hexagonal gold-plated sections which are individually controlled to focus the light onto the sensors. Inventing the technologies, ironing out the bugs, and the exhaustive testing of these brand new ideas takes a lot of time and a lot of money. And this is the other main reason why it has taken so long to get the James Webb ready. Back in 1996, when it was conceived, the original price was $1 billion and it was expected to be launched around 2007. But equally, no one at the time actually knew how to build it, and it was very much a best guess estimate. As advances in science and technology became available, more ambitious goals were set, and the time frame slipped and the price went up. It's been said that NASA projects like this are wildly optimistic and pitched low so as not to scare off potential funding, knowing that they can always go back and ask for more. But as time went by, the difficulties began to mount, and so did the costs. This meant that NASA had to keep going back to Congress for more funding, which took more time and delayed the whole project. This repeating process has gone on and on until now the total is expected to be just shy of $10 billion, $9 billion for the development and building, and $810 million for running the mission for 5 years. The problem for the government is that if it pulls the plug, then not only will science be losing a highly anticipated tool, but they'll have spent billions with nothing to show for it, which in some ways would be worse and makes it almost too big to fail from a fiscal point of view. Some have said that it was all done backwards and we should have built it with existing technologies that have a known price tag. The problem with this argument is that it would have never been built because we didn't have the technology. And waiting for someone to invent it without an end goal just doesn't happen. If this methodology had been applied to Apollo, we'd have never gotten to the moon. This will become the most highly scrutinised project in space history so far, but they can console themselves that it looks an absolute bargain compared to the $400 billion for the development of the F-35. So I hope you enjoyed the video, and if you did, then please thumbs up, subscribe and share, and don't forget that Patreon supporters get ad-free versions of videos before they're released on YouTube.